Okay, again, another short topic, area of a sector. So we've got a circle again, and the piece of the pie that you cut out like you're playing Trivial Pursuit, that shape is called the sector. Okay, so I've got a centre O, I've got a shaded area, and that shaded area is the area of a sector, and I'm going to call that A. So copy that down, but if you're happy that you understand that, then come across to the next slide when you're ready. Okay, so I'm going to do this proportionality again. So I've got a full circle. The area of a full circle is pi r squared, and the angle it went through to get a full circle is 2 pi radians. So I'm going to do this proportionality again. So the area of a sector, okay, so the area of a sector, which goes through an angle theta. So, oh, sorry, wrong sort of shape. So I get my circle. So it's gone through an angle theta, and it's got an area. Okay, so the area of a sector going through an angle theta will be proportional to the full circle going through a full angle of 2 pi. Okay, so then I cross multiply that up to the other side. So I've got theta over 2 pi times pi r squared. The pi's cancel out. And so this 2 here is the half. So that 2 there is a half. There's the r squared, and theta is there. So that formula is called the area of a sector. But again, the angle must be in radians. You cannot have the angle in degrees and get the answer. So the area of a sector is a half r squared theta. And just to remind you that the length of an arc is r theta. The length of an arc is r theta. The area of a sector is a half r squared theta, where theta is in radians. So let's look at some examples. Okay, so find the area of a sector of a circle with a radius of 4, and the angle is 30 degrees. So the first thing you have to do is know conversions. So 30 degrees is 30 times pi over 180. But again, that might be one that you remind. That was from our exact values, and not exact values, but those ones that are special. 30 degrees is pi on 6. So the area of a sector is a half r squared theta. So a half is a half. R squared is 4 squared. Angle is pi on 6 because we converted it. And so 4 squared is 16, 2 times 6 is 12, and then 16 over 12 is 4/3. So that's the answer exactly. And then, excuse me, you could convert that into a decimal by putting pi as 3.14 and getting it on your calculator and doing another calculation. But the answer is exactly 4 pi on 3 centimeters squared. The area is a square unit, and don't forget to put units. Okay, so example 2. A sector formed by the angle of 2 pi is equal to 12. So we know the area, and we've got to try to find the radius. So we're just going to manipulate the formula. So area equals a half r squared theta. To get the 2 on the other side, I double both sides, and then to get the theta off, I divide by theta. And then to get rid of the square, I take the square root. I can't take a negative square root, which exists theoretically, but doesn't exist because you can't get a negative number. So the radius is equals to the square root of 2a on theta. So then 2 times a, which is 12 over angle theta 2. The 2's cancel out. Square root of 12. 12 is 4 3s, and the square root of 4 is 2. So the answer is root 12, and if you don't know how to convert, you will lose marks, but that's not many marks you will lose, a little bit. But the answer is exactly 2√3 centimeters for the radius. So just in case you like to have some conversions, the main formula is a equals half r squared theta, but as I just did, I can manipulate r to the front, and if I want to have theta on the front, then I double to get rid of the half, so the double comes up to here, so it becomes 2a, and then divide by r squared, so that's the third formula. And exercise 20.2, which you were doing for length of arcs, keep going with that and just find all the areas of a sector question. Okay, nice quick video, hope you enjoyed.